Hey everyone, your favorite teacher, Mrs. Johnson here. I'm going to give you a quick lesson on raise a power to a power. So if you want to, in your note sheet, go ahead and write 7-4A. We're going to be raising a power and taking it to a power. If you need to pause the video for this, you can. Alright, we're going to take a look at some patterns to see if we can generalize and create a rule. So the first one I want you to take a look at is we've got 3 to the third power, and we're going to take that 3 to the third power and we're going to raise that to the fourth power. So I can draw this out. If I look at 3 to the third power, really that's saying 3 times 3 times 3. And if I want to take that and raise it to the fourth power, I want 4 groups of that. So I'm taking 3 to the third power times 3 to the third power times 3 to the third power times 3 to the third power again. So 3 to the third power to the fourth power is 3 to the third power times 3 to the third power times 3 to the third power times 3 to the third power. And if I look at this, I can say, well, how can I write that so that it's using an exponent, or how can I write that using a power? 3 times 3 times 3 and so on would be 3 to the 12th power. Another way to look at this, I could say, well, I've got 3 to the third power, and I want that to the fourth power. Means I have to multiply that by itself 4 times. 3 to the third power times 3 to the third power times 3 to the third power times 3 to the third power. And when I have bases that are all exactly the same, I can add the exponents. 3 plus 3 plus 3 plus 3 would be 3 to the 12th power. So either way you look at it, it's 3 to the 12th power. All right, let's take a look at the second one. I've got x to the 5th power, and I'm going to take that and raise that to the second power. So if I got x to the 5th power, I've got x times x times x. And I want this to the second power. So I'm going to take this and multiply it by itself. So now I have x to the 5th power times another x to the 5th power. And if I take a look at that and I rewrite that using a power, I can say that this is x to the 10th power. The other way I could look at this is x to the 5th power to the second power. I have this base to the second power. I'm taking it and multiplying it by itself. And if I look and I use my exponent rule, I can say, well, they're the same base. I can just add the exponents. And I have 5 plus 5, which is still x to the 10th power. So this third one here, if I have b to the second power and I want to raise that to the third power, that's b to the second power times b to the second power times b to the second power. Taking this base, raise it to the third power, and multiply it by itself 3 times. So if I use that rule where I can just add the exponents, 2 plus 2 plus 2 is b to the 6th power. Now you might be recognizing a pattern right now. What can we really do with those exponents? Well, if I take 3 times 4, I get 12. 5 times 2, I get 10. 2 times 3, I get 6. I'm really just multiplying the exponents. Let's see if it works down here. I have p to the negative 4th power, and I'm going to take that to the 6th power. So I have this base multiplied by itself 6 times. P to the negative 4th times p to the negative 4th times p to the negative 4th. Oh my goodness. All right. Well, now if I look at this, I've got p to the negative 4th. Well, I can rewrite all of this so that I have positive exponents. So if I rewrote all of this, I would really have 1 over p to the positive 4th times 1 over p to the positive 4th. One, 2, 3, 4, 5, 6. Okay, great. So now here's what I've got. So now take a look, and I've got, looks like I'm going to have 1 in the numerator, and I've got p to the 4th times p to the 4th times p to the 4th. And if I have the same base, I can just add the exponents, and that's p to the 24th. So when I do this, I've got 1 over p to the positive 24th power. Now, let's see if that followed the rule. We're thinking that what we could do is just multiply the exponents. And so if I do that, negative 4 times 6, that would be p to the negative 24th power. And I know that I just can't leave a negative exponent. So what I'm going to have to do is rewrite it to make it positive. So I would rewrite it as 1 over, because remember this is over 1, I'm going to flip it or put it downstairs, p to the positive 24th. Hey, that's what I got before. So now taking a look at this, I can come up with a rule. And my rule then would be to raise a power to a power, multiply the exponents. Awesome, now we came up with a rule. So let's do some examples. Okay, first example. I've got y to the third power times y to the fifth power raised to the second power. Well, right here I see I've got a power to a power. So right there I can use my rule. I am going to multiply the powers. So really I'll have y to the third power, remember this is multiplication, y to the third power, times, and right here I've got y to the 5 times negative 2 is negative 10th. Now I take a look at what I have, and I have the same bases, and if the same bases are raised to a power, I can follow that other rule where now I'm going to add the exponents. So here I've got y to the 3 plus negative 10 would be negative 7, and we never ever want to leave a negative exponent. So now I'm going to change and rewrite this. This is over 1. I'm going to move this downstairs, or we can use the reciprocal. So this would be 1 over y to the positive 7th power. And there it is. All of that right there, simplified right here. Okay. Let's look at the second example. Go ahead and write the second example down. Now here we've got x to the second power, and we're going to multiply that x to the 6th power, and that's raised to the negative 4th power. Holy cow, are you ready? All right, so here I notice that I have a power, this power right here, and it's raised to another power. So I'm going to use my rule of multiplying. So I can just take these two, and I can multiply them together. And that's going to give me x to the 6 times negative 4 is negative 24. And now I still remember here that I have I'm multiplying this by x to the second power. So now I look at what I have. Two bases, same bases, raised to a power. I then can use my add rule. And here I've got x to the 2 plus negative 24. Well, that would be negative 22. And again, I can't leave an exponent negative. So if I write this as a fraction, I can use the reciprocal, or I can take this guy and move him downstairs. This would be 1 over x to the positive 22nd power. And there I have it simplified. All right, ready for number 3? I'll be taking you through 5 examples today. So here's number 3. Go ahead and write number 3 down. We got v to the negative 2nd power. We're going to multiply that. You see that with parentheses. By this power, w to the 7th power. And that power is raised to the 3rd power. So get ready to simplify here. I know that this is multiplication in there. They're stuck together. But I see I have a power raised to a power, so I'm going to use my multiply rule. And so this is w to the 7 times 3 is 21st power. And I'm going to be multiplying that by v to the negative 2nd power. So now I take a look and see what I have here. And I can't leave this exponent negative. So if I write this as a fraction over 1, this exponent is going to have to move downstairs to become positive. I also explained this in class, where if you multiply these two, these are both over 1. And what I'm doing here is I'm using the reciprocal. And when I use the reciprocal, that v to the negative 2nd is going to move downstairs. So v to the negative 2nd, let's pull them downstairs. W gets to stay upstairs because it's got a positive exponent. V to the negative 2nd is going to come down and become v to the positive 2nd. And there I have it simplified. Okay, last one. Go ahead and write down that one. We got s to the negative 3rd. We're going to raise that to the 4th power. So again, I'm taking this power to a power. And then I have another power that's being raised to a power. Looks complicated, but it's going to be very simple. So I'm going to use my power to a power rule. I've got s to the negative 3rd, that's a power, and I'm taking that and raising it to another power, so I know that I can multiply. So I've got s, and negative 3 times 4 is negative 12. And remember, there's a big multiplication sign. We got 2 parentheses stuck together, so let's multiply. So now I have r, and I've got a power here, r to the negative 5th power. Raise that to the negative 2nd power. I can multiply.
Frida Martin to the office, please. Frida Martin to the office.
So I have r, and negative 5 times negative 2 is positive 10. Okay, so this is what I have now. Now, if I write this all as a fraction over 1, who's got to move downstairs? Well, this one right here, negative exponent. Let's move that downstairs. The r to the 10th gets to stay where it is because it has a positive exponent. And s to the negative 12th, we're going to move that guy downstairs. And when we do that, it will become a positive exponent. So there it is, simplified. R to the 10th over s to the 12th. Okay? Get ready for number 5. Okay, here's 5. Now here you'll notice that number 5, you have a square, and we're asked which of these 4 expressions, A, B, C, or D, represents the area of the square. Well, what do we know about a square? The side lengths are equal. So we know that if this side is the expression 4x to the 5th power, the other sides are also 4x to the 5th power. And I know that if I take the 2 sides and multiply them together, I'll get the area. So being that both sides are 4x to the 5th power, I'm going to be taking the length, which is 4x to the 5th power, and I'm going to multiply by the width, which is 4x to the 5th power. And this expression here is going to give me my total area of the square. Now, just like we talked about yesterday, we're going to start breaking this up a little bit and saying, all right, well, I know that 4 times x to the 5th means I'm going to multiply those two. I got a number and a letter stuck together. And here, 4 times x to the 5th, I'm going to multiply that there too. And because multiplication is commutative, I can switch the order of the numbers I'm multiplying. So I could rewrite this as 4 times x to the 5th power times x to the 5th power. And now simplifying here, 4 times 4 is just 16. And here, I've got x to the 5th power times x to the 5th power. If I'd expand that, it would be x times x times x times x times x times x times x. Remember, we can just do that a lot faster and use our add rule. I really have x to the 10th power. And then I look at my answer choices here and say, wow, it matches up perfectly with answer choice C, so that must be the answer. So there you have it. This is multiplying, where I have a power raised to another power. And I use my rule that I just multiply the exponents. So I'd like you guys to give this a try, and you're going to be giving this a try on the 7-4A worksheet. So I hope you enjoyed the video, and I'll see you next time.